All right, looks like it's live. Anyway, welcome on in, whoever's watching. Some music on here. So yeah, last weekend couldn't really do any streaming because I was out of town, so we'll be continuing today. So today I'm going to just be some more analysis of the TMNT1 code. I was doing that around maybe 2 weeks ago or so, and it has made progress, but I intentionally left a lot of the music engine stuff alone, just focused on some other areas of the game. So, I think with that said, yeah, let's just change views here. Hopefully OBS will cooperate. And yeah, it seems like it has. All right, good. So yes, like every time I open OBS, we have to reset this stuff every single time. So, I can't remember, VS Code. That's like, remember specific VS Code, and then even then, it doesn't remember the instance of it. So let's see here. So yeah, since last time, I've actually assigned a couple of names to some of these parts in the main loop. And let's see here. Sorry, lost my train of thoughts here. So things like, setting the scroll, updating the music engine, updating the state. So it's also a big one. Actually, since updating the state's kind of obvious, we don't need to really have that comment there anymore. But yeah, today's focus is going to be on updating the music engine. So in the debugger over here, I actually have it highlighted to go to that point in the main loop. So let's actually reset the game first. Take off this breakpoint. Actually take off a couple of breakpoints. Display out. We'll put this point back on. Yeah, that's one of the annoying things. Every time you reset the game, you have to re-import your labels into this. But yeah, so one more time. Let's see here. Yeah, right here. Okay. So actually in the title screen, I think we're going to do, before we even do this. So the main goal today is to try to figure out, exactly what all the various parts of the music data do. Like last time I determined certain things are effects, things like a note rest, for example, or a jumping to a pattern. And so probably the best way to do that, I thought, would be to, actually go through an entire song. The thing is, though, the title screen is a bit of a complex song. But one thing we actually can do is actually change the song up the title screen to be a more simplistic song. So if we kind of, I'm not going to run through the game debugger, but if we update our state and then I've named title screen, and I think right around here, yeah. So I've gone ahead and assigned a couple of names to the songs in the game. Macros, aliases, music. So I'll put this over here. So like title, for example, is 4E, overworld and whatnot. But one of the most simplistic songs in the game, and it's not the most exciting, is when you're underwater and you have the low time, playing that sort of warning music. And that music I think would be a good one to do, just to figure out all the music data, because that should have all, the parts of a song, notes, and then a looping point. So what we're going to do is actually have it so the title screen, instead of playing the music, we'll instead play a low time song. So, build the game. Alright. So we've done that. So now take off our breakpoint and then I'll reset again. Now when the title screen comes up, oh, I didn't reload the game. Oops. That's kind of important. Actually, yeah, a second, let me turn off the other background music here. There we go, so we can actually focus on this now. But yeah, you can hear, it's actually playing the different song here on the title screen, even if we press start and reset. So this is pretty much like a 4-measure song. So yeah, we'll go ahead and figure out this data. So back in our code here, I've actually figured out, this is where the data lies in the game. So you have our 4 channels. I've also figured out since last time, it seems like noise and TPCM are actually combined into one thing here. So yeah, last time when I was looking at the title, I made a mistake of thinking, there's 5 different channel pointers, but no, there's only 4. So yeah, they're grouped, TPCM and noise. So yeah, let's try to figure this out then. So what I'm going to do then is more time. Where should we put our breakpoint here? Sorry, just going through code here. So yeah, we're not too concerned about playing the new audio since we figured that majority of that out last stream, but more interested in just analyzing the data itself. So update music engine. So let's do that. Reset the game. All right. So it played a tiny bit into the song, but that's fine. So first, import our labels. And then go down to the update music engine, which is here. Step into that. We're going to go down to this instruction here, which goes into bank 0, 8644. So that's where the actual music engine starts. And in fact, yeah, I did actually give this a name, so a more appropriate name instead of 8644, the music main loop start. In fact, let's save that. So we can turn on the background music again for the stream. All right, so let's go through one iteration of the loop. So 8612 is up here. So that flag is obviously not set, so we don't concern ourselves with that. So we back up our two registers, X and Y. Check if the channel has a song ID, which it does. And then we're going to update the current channel. Oops, wrong window. So yeah, determine that this does in fact create a pointer to the channel, so we don't need to bother that instruction. So now, let's see. So when the note holds, it has some counter for how long it's supposed to hold. And if that counter has not reached 0, then it continues to hold. So I'm guessing it's probably hasn't reached a 0 at this point, or compare our channel. This channel is not triangle. Yeah, this 1116 is also something we gotta figure out what the heck that's for. Okay. B0. So note countdown is E. E was not greater than that, so hit exit. So we're then jumping to look at music effects. Oops. Oh, what the heck? Clicked the wrong button. There I do. Another iteration. Yeah, I hit step out by mistake there. Alright, one more time, switching to the bank. Alright, so we've yeah. So back up X and Y. More time loading our song ID. Update the current channel. Create our pointer. And decrease our countdown. So since I hit the wrong button by mistake, the countdown is 1 less than before, but that's fine. Okay, so we're not on the triangle channel. All right. I'm wondering if more practical thing to do. My debugger a little bit wider here so I can see it. Right. Going to the next channel. In this case, it's going to be D. I think it would be best if we got it to where this was a 0. I think we're going to do a change of plans here. Because it calls the music engine every frame, but we're going to get to where it's kind of calling the song when it first starts, and then advance a frame or two after that point. Some more time. We'll reset the game. Import our labels again. And then go to our NMI. So where does it actually cue the title song? Oh, here we go. Okay. So around C5, D9. All right. Take off these breakpoints for the moment. Except, no, I'll leave that one, of course. All right, we got to there. Now, go back to our NMI. Advance one frame. Advance to there. So back up our registers, create our pointer, or don't create our pointer just yet. That's where we create our pointer. Skip over that. So now we decrease the countdown. In this case, it is a 0, so we're going to go here. Carry is clear, so we're gonna branch. Alright, here we go. So now we're reading our pointer, which is let's see if we can move this over just a little bit. So over here, our pointer is right here at AC5D. Then we're checking the upper bits. In this case, it most definitely is greater than that, C0. So we branch down to here. So effectively, the way the effects work is that the upper 2 bits kind of signify that you have an effect. So you're going to have, what is it? C, D, E, and F. It's the lower 2 bits of the upper bits which actually signify an index. So like in the case of C, that would be 0, because when we AND that, that just takes those upper 2 bits away. And then D would be 1, E would be 2, and F would be 3. Because we clear the bits and then shift it over for lookup index. And so E2 is going to be our pointer, so we create a pointer to our effects. In this case, we go to instruction, or sorry, we go down to 8D70. So in this case, I've actually kind of dubbed these like the, A, B, sorry, the C, D, E, and F effects. So these are the E effects. So is A greater than 6? Yes, it is. Oh, hello, Wally 4000. When am I porting this to C? Nah, you gotta have the pure 6502 assembly. That's the way it is. Anyway, hope you're doing well. Yeah, just trying to figure out some of the music data. So the tentative plan here is to actually figure out a more simplistic song in the game. So in this case, it's not the most exciting song, but it's when you're low on time in the water level, it has that very short piece of music. So you kind of look over here. This is the entire song is just, this bunch of bytes. So right now what I've determined is that if you have a byte which starts with either C, D, E, or F, that signifies an effect. And so when I was tinkering with this off stream, seems like then 0 through B are the actual note tones, which would make sense too, because in BattleKid's music engine, it's kind of the same thing, because you have the, was it 12 tones. So just got to figure out what E is doing before we can continue. But yeah, hopefully we'll be able to figure some of this out, and then maybe change the song a little bit. So anyway, the E effects. So basically, the lower 4 bits. Could it be a pause? No, I've determined that was actually the C effects. Those are the note rests. But yeah, good question. Like what because in these music engines, you of course have your rests, but you can have things like you know, setting the note length, setting the instruments. You can also have other things like, you know, jumping to patterns, so you don't hard code the same notes time and time again. You could, you know, repeat the same note pattern a couple of times. So so we're going to comment here about our E effects. The lower 4 bits a value. So in this case, the value was A, which is 10, so that's going to be greater than 6. So you branch down to here. And then we're going to subtract 6 from that value, so that's going to make it 4. So basically, if the value is greater or equal to 6, it serves as a lookup index for another indirect jump. So if it's less than 6, then it's something else, but anyway, in this case it is, so it's 10. So 10 minus 6 is 4, so that's and then shifting left. Hey, really? Yes, okay. Yeah, clear our bits, subtract 4. A is now 8. And so we then go to 8DE5. Alright. So there's our indirect jump. 8DE5. So we're missing a label I'm missing here. Let's put that in. Save that. So we increase our pointer and we take another argument, which in this case is going to be that 8-1. If that's a minus, which in that case it is a minus, take our branch. So actually going back up to the E effects, it would help then to actually document what the follow-up indexes are. So space follow-ups. So in this case, A has one value following it. Okay, the more of this we figure out, then the more we can actually experiment. So anyway, yeah, it's a minus, so we're gonna take the branch. Shift A left. So now it's 2. Instead of being 1, it's now 2. And once again, we put an minus bit on it, and we jump. So in this case, actually, let's put a little note here. This is effect EA. Takes 1, follow, up, value, negative, yeah, if positive, it does something completely different too. Wow. So yeah, that's one of the fun parts of good old 6502 is, you know, you just use the bits to their full potential. You know, 8 bits in one value. You could potentially do, you know, 8 different things with each of those bits on or off. So it looks like nothing actually branches down here, so let's put a little dividing line on here. Actually, yeah, that's even better. So that's basically isolated now. Alright, then let's put this label in Messen. Yeah, when I off-stream, like, converting the code, like from bytes to actual readable code, sometimes I forget to put the labels in Messen. So alright, we're up to 8D EB, which is up here. Store this into 161. So 161 is now 82. Jump back up. Oops. Jump back up. All right. So now we're going to check the next effect in the song. So effectively, that's going to be this D instruction. So there's a note here. Yeah, as we slowly figure these things out, I'm using this as an example, but writes, or rather, eventually writes 822161. Hopefully, you can see this okay, yeah. More Tarokos needed. Yeah. Yeah, code analysis is pretty chill though, so. But yeah, like last time I was doing this, we had a lot of people talking, so, you know, feel free to, you know, talk about whatever too. I mean, I'm just doing this and talking out loud as I do it. It's like a puzzle. Yeah, it is. But one of the things is once you actually uncover a certain memory, then a lot of things suddenly just make a lot more sense because, you know, instead of having, you know, 161, you know, what does 161 actually do? But once we figure out the rule of 161, like, okay, this function makes a lot more sense, and so do all these other functions. But anyway, let's see here. 8925. Step by step. Yep, step by step indeed. Like, this is the case where we actually have the solution, but we're trying to figure out how the solution was actually made, so going backwards. So once again, so we have our D effect here. So we're gonna take our indirect jump, in this case to 8D22. 8D22. And yeah, the D effects were something we also found last time as well. So D effects, not some kind of effect. Followed up by 3 values. And we also determined that if it's the triangle, it's only followed up by 1 value. Or it's followed up by fewer values. We have pulse channels. So knowing that, 1, 2, 3. All right, and also the lower 4 bits. Okay. Lower 4 bits get stored into 0110, x. Maybe we should write 62110. And in this case, x is index 0, so it's going to be 110. Okay. Increase our pointer. Get the value of 33. And in this case, x corresponds to the channel we're updating. So in this case, it is not 2, it is 0. So that's not going to take. We clear the lower bits of A. Write that to 158. I think we'll actually group this a little more. So the 33 writes 30 to 158. But we're doing more with this, it looks like. So now we're writing 3 into 152. So, wow, they take both of these and, okay, 2 separate places. Writes 03 to 152. All right. Then we've upped our pointer. Center this a little bit better. We take this 17 value and write that to 164. All right, so writes value as is to 164. branch if plus, which it is, 28D44. So then we reload this value that we wrote to 152, store to 176. Since it's positive, also takes 152's value and writes to 176. So once again, increase the pointer, and this is our third follow-up value, which is the 15. And we take the lower 4 bits, store to 170. Right. 05 to 170. Reload. Shift right 4 times, so that's going to be, so 10 becomes 1. Store into 172. So shifts right 4. Writes 01 to 172. Branch if not equal. In this case, that's going to branch because 1 is not 0. And we write 1 to 174 as well. Sorry, and to 174. And then we go to our next effect reader. So it's going to be this E9 instruction here. So now we're back down to 870, our E effects. So in this case we're doing 9 instead of A. So 9 is greater than 6. Subtract 6 gives us 3, which is going to be a lookup index of 6 when it gets shifted. And that takes us down to 8DB8. Alright, this is effect E9. Actually, I'll leave this here. Effect E9. And yeah, let's put a label in Messin as well. Kind of wish that I could have done a stream when I figured out the gimmick music engine as well, because that's even more complicated than this. But I did actually figure it all out, but gimmick, on the other hand, felt a lot more competently programmed. But hey, you know, everyone's different. I'm sure once we do figure it out, it'll be beautiful. Alright, so, upper pointer, let's take our follow-up value of B1, branch if equal, which B1 definitely is not 0. Alright. we got with B1 is take the lower 4 bits. So 1 is not 0. We reload in our B1. Let's see here. So comment is checks if actually here. Why am I writing this in the song data? Checks if lower 4 bits are 0. Well, actually, no. First checks if value is 0. Checks if the lower 4 bits are 0. Then what eventually happens, B1 gets written to 1AC. Writes B1 to 18C. We load in 116, which is 0, probably because the song is initialized. Or initializing. So I'll look at my memory map. Did I have any notes about 116? Because some of the memory I did for sure figure out things like the pointer and the countdown, which is like how long the note holds, but okay, nothing about 116. All right, no problem. Alright, so now you love 116, oh I might, yeah. So I'm more eager to get to the actual note tones. So writes B1 to this data also writes 20. Oh wait, is that right? Step back. Alright, writes 20 to 116. Yeah, once we actually get some names on some of these, it'll be a whole lot better. Alright, step. We're going on to the next effect, which is an F effect. So you can kind of see as the and this is very typical, like for songs. It's like when they're initializing, you want to do like all kinds of setups. So you'd have EA, D6, E9, so some effects here. And you have F here. I think, if I remember right, this FD, which is going to be coming up here, this is actually a jump effect into the song, and because when you think about that song, like why am I talking about this? Here, let's actually play it. So I'm going to open another emulator. I'm going to open up FCUX in the background here. You're not going to see it on screen here, but you should be able to hear the modified title screen music. Let's turn that up just a little bit. Because it goes to that dun 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 dun, then it does that again. So most likely then the pointer is going to be where the notes get repeated. So let's do that. Let's see here. So we're loading in FD. And in this case, jumping to 8E66. So 8E66. And yeah, here we go. This is something that was from last stream as well. This is effect FD. So compare the lower, or sorry, not specifically FD, but sorry, these were the F effects. So yeah, let's yeah, it's sorry, it's kind of picky, but yeah, you want to try to make the source code at least somewhat uniform. All right, let's put on some background music again. So the F effects are basically dependent on their lower 4 bits. So it compares the lower nibble to a few values. So the first one it checks is FE, which is just E in this case. So obviously we're not going to be doing E. D, on the other hand, this is what it is. So branch equal. Yeah, there we go. Yes, I think we definitely did this on last stream too. This is effect FD, which triggers on a value of D, although that's whatever. I'll clean up the comment later. And yeah, so okay. Here we go. So going back to the music data, what follows FD is actually 6C AC, but that's actually an address, which is AC 6C, which is good old little endian, which is the 6502's. Well, not just the 6502, it's just the way the 6502 handles its addresses. So AC6C, I'm going to make a little pointer to that. Eight. Should start right here. C. Yeah, I should come up with better names for the labels other than just music data. Kind of like, music header data and then music sub data or something like that. In fact, let's do that. Kind of like music sub data. Just to differentiate it from, the main channels. So we're going to then jump to here. So kind of going through the debugger a little bit. what it does is it saves where the pointer is currently in the song, because we're going to jump to a pattern, but then we're going to come back to where we currently are. Going back to 82. Oh yeah, good, good. I even have these names here. So instead of 13A, that's actually the RTS low address. And then the 140 is the RTS high address. So yeah, that's good. We got those uncovered in Messen. So yeah, we create our return address. We load in 116, which we had set previously. We know that we're jumping, but put a note that by jumping 116 it's set to 28. Now why it gets set to 28 we don't know, but that's okay. And we jump down here. Then we once again create a channel pointer. Rather, kind of like we recreate our channel pointer would be a better way of putting it. Then we load in good old 116 again. Oh man. Shift right. Carry flag, so 8 is going to shift to 0, so that's not going to trigger the carry. We're going to then jump to 925. Oh yeah, 8925 is then the go on to the next effect. Alright, we're making progress. Now the pointer is down here at its new jump location, AC6C. So once again we're going to go down to where the F effects are at 86.6. So now, looks like the B is going to trigger now. So compared to E, no. Compared to D, no. Compared to B, yes. So here we go. Yep, so this was effects FB. Increase Y, transfer Y to A. I'm going to add on to our pointer. So in the comments, I thought this was maybe another JSR routine. Like you could kind of jump to a pattern within a pattern, so you could have like all kinds of, repeats within repeats. I'm not sure if that's the case yet, but it's definitely creating a pointer. So it's backing up AC6D, which is this instruction here. All right, put in binder. And again with 116. In this case it's 28. So when it triggers, it's going to then reset. I'm wondering, since it backed up the address, but it didn't actually seem like it changed where the pointer is. I wonder if FB is like some sort of maybe like F. Yeah, I can't really guess at this point what FB is supposed to actually be doing, so we'll just roll with it. Alright, moving on to the next location, which is AC6D. And that is E4, so it's another effect. Well, really uncovering the effects in this song. Quite a few effects considering it's a very short song. Going up to 8D69, so these were or sorry, 8D70. Okay. Alright, so in this case, it's E4, and 4 is less than 6, so we're going to actually see the other part of this code now. So going back over here, F4, not quite sure what that's doing just yet. So this is writing a value of 4 into writes 04 into 15E. Increase Y. Alright, looks like we're done with the effects. Because the next value is less than C. So we'll go through that. Put in our value. Wait, did I miss something? Okay, here we go. Compare to C. In this case, it's not C, so this is going to actually play a note. So this is going to go to 8B, 3E. Play the actual notes. So values of 0, 0 through EF in music data. So looking back over at the music data then, trying to think how that song goes. It's like da 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 da. It has to be something with pitch and note length, though, as well as octave. Alright, B3A, so first we're gonna jump to here. Load in the value. Take the lower 4 bits. And E2 is temporary memory. Here we press stop. Takes lower 4 bits. These are right up here. Takes lower 4 bits. That's up into E2. Yeah, E2 is, some kind of temporary memory for all this stuff. Because it's used for pointers, but in this case it's definitely not being used for a pointer. Alright. Takes 0, 2 portion. X up in E2. I think 110 was... No, don't have any notes on 110 just yet. But no, we did have that from earlier though. So 110 was 6 from the D6 effects. We add 110 to itself, making it 12. Decrease E2. So this is a loop. So, okay. Go back, go back. No, go back even more. Load in 6. 6 plus 6 is 12. Decrease. 6 plus 6 again. Or sorry, 12 plus 6 is 18. E2 is now 0, so we don't care about that anymore. So this code here is just going to be skipped. Yeah, all these use cases. So basically, if lower 4 bits are 0 on here. If lower 4 bits are greater than 0. Well, for right now, come here. Okay. So it looks like we then have a countdown, which is the how long the note was supposed to hold for. So knowing that, maybe then D6. So maybe the 6 is supposed to represent a note length. Well, no, that would make... Would that make sense? Would that make sense? Possible, right? Oh, I wonder then, because something would have to then represent the octave, though. So maybe countdown might not actually be the right term for this. Alright, let's continue on. So is it greater than or equal to the triangle channel? No, it's not. 116 was 28. So A is definitely 0 in this case. Add this over. It's probably over on the triangle. No, on the noise. No. 170, which was a value that came from D6. Man. It's a good thing that I've written down, you know, all the steps thus far. So now we're going to go down to here. It's HCBD. So we take our 5 value, which came from the D6 instruction, store that. 0 in these. So the 5 is some sort of iteration counter for this. Sounds it. There's an iteration counter. 8cc7. Take our 112 from earlier. Add 0, so it's the same value. Same value, so this is just going to do the same value. That exits. And a sec here. So basically the note, or not the note, but the value just keeps adding on to itself so many times. Shift it around. It's a lot to take in, so I'm going to come back to that. CAD. Is there anything about 16C from earlier? No. Man, alright. Continue. Return going to 8B3E. Oh, we're not on the triangle channel, so we can, yep, skip that. jump up here. (116). So we care about this instruction. This is B1 from earlier, from the E9 instruction. Oh wow, we clear the bit, and then 116 is back to 28 again. Huh? This is the 17 value from earlier. Alright, so 164 is the value of 717. Shift. So now we have a value of 2e, which is in lookup index for this. Oh wow, this is in a different file too. BF5B. Alright, so that's in progress. The value serves as an index lookup. I think this might relate to volume. Let's go back here. Where was that low time song? (17) serves as a lookup index for table E0, possibly volume related. So that creates a pointer. So BF5B. here to FB. Well, it's definitely not greater than FB. And it's definitely not less than 10, so shift. Oh, here we go. 168 seems to be a lookup for this particular. All right, that's good to know. For this particular pointer. Not going to give it a name just yet, but possible current volume. Maybe instrument would be better. Pointer index. And we clear that. Just 4 bits. That might be a volume control actually for C, because the volume can be a value of 0 through 15. Store the value and immediately OR it with itself, so it stays itself. Okay. So it's possible volume and instruments. Okay. Alright, so 9 is a non-zero number, so subtract 176.3. That does not go below 0. So I'm wondering if 176 and 194 are some kind of volume controls. Channel volume controls. And maybe 197 is like a global volume control. All right, let's actually try some of these theories out. Yeah, I wish I could. I wish I could actually display some of this on the screen here, but it's going to be a pain to set both MESN and FCU up at the same time. One sec here. All right, before we do this, save our labels. At the same time, though, should I do that? Because probably best to go through one iteration of the loop before actually testing some of these theories out. Let's get through the iteration of the pulse channel and events, and then we'll tinker around with the other, the actual data. Because yeah, eventually it does write something to, or it might write something to. Oh, there's a lot of instances of this. X up A. X to 6, which case it is true. See if we have a oh, this memory is mislabeled. That's what was throwing me off there. It should only be 4, not 6. There we go. Security's clear, so rate our value to 4,000. To be 48. Do that. Then 116 got its 2 cleared. So once again we load in our tone. Shift right 3 times. Push A. 161. I think this might be where we actually get the tone. So we don't have to worry too much about this. No. 8D, 8A. Open another instance in here. Oh, got the wrong file open. Okay, this is promising. Hey. So these are pairs. Okay, the data comes from this table, so yeah, I'm pretty much thinking that these are, what are the actual tones? Reload in X. Yeah, man, we keep like reloading in that backup register X and then changing X immediately afterwards. 5, it's definitely not 5. Oh man, okay. Alright, so the 4 acts as an iterator for this loop. And then it's your eight B 9D max value of 5. Alright, so in this case, it most definitely is 5, so it's going to exit. So we reload in these values, 5, 7. One, 7. A and 17C are possible note pitch, door, or pulse channels are possible low and high. All right. We're getting there. 8BDA. There's the triangle channel. It's not. No. Compare X to 5. It's not. I think at this point, I'm probably gonna speed through most of this because, yeah. It does some calculations to write to 4003 though. Yep, this is where it's doing all the final calculations. So let me update our pointer. Rather we take the 0-page pointer and then restore it, and then put that back into memory. And yeah, there you go. Go on to the next channel. All right, so that was the one iteration of just the pulse channel of the loop. So we did figure out, or a good chunk of like where the effects go, and made some guesses as to what they actually do. So I'm gonna make a save up here. So now I'm going to do something a little less scientific and then actually start editing the data directly and see what kind of results we get. So let's see here. Turn off the stream background music. All right. So I'm going to just turn off the breakpoints and messing. So yeah, I'll definitely go through more of this later on my own. Try to look for the other effects. Okay. Let's see. Make another save of the labels just in case. See, build the game. Yep. Okay. All right, let's go through some of this data now. So, we want to do is let's actually change it so just the one square wave is playing. That a little bit louder. There we go. All right, here we go. So let's try modifying this data. In fact, we'll even put this right over here. So it's like do 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 do. All right, first let's modify. So instead of like 1, 2, 3, let's maybe change it to something like, I don't know. I have a feeling that F3 is supposed to be like a return command. So let's not F3, FE. That's what I'm saying. So pick stop, notes, play. So if that's going like do, 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 do. Let's copy our original notes here. And I don't know, change to like 2, 3, 4, 5, 6, 7. See if it sounds different. All right, I guess we're going to turn the debugger off for a bit. You know what? This might actually be the other pulse channel. Oh, one sec here. Yeah, got that wrong. All right, turn off the DMC too. All right. One sec here. Reload. All right, since we know that, let's actually use the info that we have. Because yeah, this game actually does the harmony in pulse channel 1 and then the main melody in the second pulse channel. But since we know how the effects work, it does a similar setup. E9, EA again. And FD then goes to that very same label. So I'm wondering if some of these effects might have to do with the pitching of things. we'll find out. So let's see here. Let's do that. Build, reload. And actually, before we reload, change it so that square 2 is the main channel. All right. Reload. All right, so that's what it's supposed to sound like. Now, if we, comment this out or something and change it with, let's, instead of changing the first, but let's change these numbers at the end to see if that affects. So instead of like 1, 2, let's do, I don't know, 1, 5, maybe 4, 3. Science, yes. So I did one iteration of the loop, so now I'm going to actually see if it sounds different. So here we go. Let's see. Well, that is definitely different. Do 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 do. So okay. Do 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 do. What happens if we change, like, instead of a 1, let's maybe use B A 9 8 7 6. See if we have some different note pitches this time around. It's definitely going down. So I'm thinking that the way it is structured is that the first one is actually no, NES is little endian, or rather 6502 is little endian. Yeah. So what I think it is that the second, sorry, the lower bits are the note length, and that the upper ones are definitely the note pitch. So let's put it back to the 222000 and see if it. Yeah, definitely. But that's also doesn't make much sense though, because it's like do 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 do. That's 9 tones, but only 6, 6 right here. So I'm actually wondering then if these might be indexes for something else. So what happens if we make these 0? Yeah. Yes, thank you, VS Code. I don't need the IntelliSense for this. Okay, that definitely was different. Do 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 do. All right. 3, 3, 3. So I think 3 is a C, so interesting. Some more longer values. 3. So this is the less programmatic part of the stream and the more just playing around with values. Sorry if you can hear that TV in the background. That's why one of the reasons why I have the background music to try to cancel that out, but all right, so going through this, because yeah, then just look at the end of the song here. All right, first let's put the song back how it was. Yeah, not sure why we have the FE instruction right there. Actually, you know what? Let's take that off and see what happens. This might break after one loop though. This must be maybe some kind of repeating instruction. FF is definitely going to be a terminator instruction. Because the song goes like do 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 do, then a little bit higher do 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 do. So somehow these values at the very end it goes like do 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 do. All right, build. Reload. Let's listen one more time. Although I might also be do. There's probably actually something in the volume that is making me think there are more notes than there actually are in the volume envelope. In fact, let's do a quick look at. If I remember right, it was I guess I don't remember right. Should have written. I should have. I think it was the PF. All right. One time. Just, so it's like a really long length this time around. Let's do like, F, 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 and I don't know, E, E, E. Okay, that's what it's doing. It's doing like, instead of like do, 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 it's just doing like the do, then the volume goes out and then it comes back. That's what makes it sound like two tones when it's actually just the one tone with the volume cutting out like that. All right, so we've got it, I think. So it's like do, 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 do. Then one more time, do, 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 do. And then here, do, do, a little bit lower. Rather, the first note is lower, but the rest of it is higher. Do, 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 do. In fact, so these are like, this is like measures 1 and 2. This I want to say is measure 3. And then this would be the last, measure 4. So what if we instead start with measure 4 instead of measures 1 and 2? Huh. I wonder if the FB and the FE is like some kind of sandwiching instruction. So like anything between those would actually get repeated. Well, let's test the theory. So instead of E being up there, let's put FB down here and see what happens. The only thing, though, is that these notes were sounded lower than they're supposed to be. So maybe that's what the E4 is supposed to also do. Should give this from to stuff. WTF. Stuff is the stuff is stuff. Yeah, yeah. No, he knows that I was tinkering around with this. Yeah, it's you're definitely seeing a very 1980s thing here, where we had to, because if you actually kind of look at this file, this whole file is a bunch of bytes. So this is, 8 kilobytes, and this is a lot of the music data. And then if we look at then this is the remain. Why did it resize the window like that? I didn't want that. Thank you. So the actual data itself starts at 9.1. So that's what, 8 kilobytes plus just a little under 4. So the entire game's sound effects and music come to a total of around just under 12 kilobytes, actually. So, how do we make 12 kilobytes into something audible? And that's music and sound effects, not just music. And then the actual music engine is, what I was going through earlier. That was the, shall we say, maybe a less interesting part of the conversation, but still, kind of figuring out that stuff. So let's go back to our song. You're back? Sure. Yeah, I'll be here. All right. So just going back into this. So I'm wondering if this is a octave pitching thing. So let's change E4 to E2. See what that does. Yes. All right, we figured out that. So there was the E effects. So going back to the E effects, the value is greater or equal to 6. It's an effect. If it's less than 6, it serves as an octave pitch. Yeah, I'll say an octave pitch. For example, E4 is +1, E3 is +2, etc. So if we were to set this to, I guess, E0, that would be the highest. Yep. But it plays those last little bits of notes. Ah, that's what okay. That's what the E5 is for. Yeah. So we figured out the E effects. So this E value, I don't know if you were listening the whole time, but is an octave pitcher. So like E5 is normal. I guess for the purposes of iteration, so it's basically 5 minus. So like 5 minus 5 in the case of E5 would be 0. But in the case of E4 is 5 minus 4 is 1. So that's a pitch up of 1. So you can pitch it up to upwards of 5 minus 0, so 5 octaves. So E4 was what it was using. Okay. And then FB serves as some kind of like a sandwich sort of thing. So, all right, we've got that. Now, and then towards the end of the song, because you were kind of hearing the higher pitch, I'll actually unpause it. So those last few notes, it actually pitches back to the 0, which is this E5 here. So, okay. Okay. We figured out pitching. So let's, again, save our original data. Now let's see if we can, for example, let's do 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8. So this should be like this, in theory, the same tone, question mark. Okay. So yeah, I guess we did figure that out earlier, but it's just coming back to me. So you have your tone, then you have a length which follows the tone. So you would need to do that octave pitching. Wow, that's actually kind of a pain, to be honest. Because it would be my instinct to, instead of, have the note and length together, I would have something that would set the length and then have the octave and notes together if I were to make the music engine. But yeah, I guess it works. So going back earlier, we made a note about some kind of lookup index for, I think, the volume. It's an iteration counter. Didn't we have a lookup index for that? Oh well, enjoy some broken music while I think about this. Ah, yeah, this 1/7. So instead of 1/7, let's actually change this to, I don't know, 1/6. So we might have a different sounding instrument this time around. Instead of this little 25% square wave, what do we got this time? Did I build again? Change it to something very different, like 1, 2. Okay, so that's definitely not what that was for. There's got to be a way to change the instruments. Well, let's do the fun thing. Let's just do these one thing at a time and see what actually changes. So, all right. Initially, this was EA 8.1. Let's try EA 9.1. Sounds the same. I want to get a different instrument, so 3, 3. How about 1, 1? Although wait, I just realized I'm editing the wrong data. I'm editing pulse channel 2 when I'm supposed to be, I'm editing pulse channel 1 when I'm supposed to be editing pulse channel 2. So that was my bad. Programming is fun. Pulse channel 2. There we go. This is the triangle, and then this is the noise slash DMC. All right, so if anything, I think my original theory was right. This, instead of 1, 7, keep the original data. Let's do, yeah, something like 1, 2. See if that sounds any different. Yep. That is definitely different sounding. Let's put it back with the original notes. So there you go. Where it doesn't have that volume cutting out anymore. So alright, so effect to D6. Or rather, not specifically D6, but the D effects. In the case of the pulse channels, the second of the 3 values is the actual instruments. So value 0, not sure just yet. Value 1 is the instruments lookup index. Value 2 is, again, not certain. And that would make sense, too, because the triangle doesn't use those last 2 values. Because, you know, the triangle is just the triangle. Alright, so we've got that. Let's experiment with see what we change value 2 to something like, I don't know, 1, 6. How about 4, 4? See what that does to the song. What if we make that value 0? Sounds like the instrument's holding a little bit longer. So in the case of 1, 7, I'm actually gonna begrudgingly count down on these to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16 is 1, 0. 1, 2, 3, 4, 5. Really? Sorry for the repetition here. Huh. Alright, let's, instead of doing that, let's try the 7, 0 value. Maybe 4, 0. That sounds different. Maybe 1, 0. Ah, this might be the duty cycle. Try 2-0. 3-0. Of course, then again, I think this might be a bit-by-bit basis too. Because every time we set 1 to 0, it starts sounding different. Hmm. I'm gonna try well, editing this data. So I think this is the instrument data, so I don't do that. We change it to 2-0. And we'll change this back to the original data. Sounds the same. Well. All right, let's restore the data for now. And we'll restore this data as well. Let's actually, instead of doing this, let's actually maybe do another song in the game. So, yeah, this was some pretty good progress on this one simple song. But, you know, once you know how the simple stuff works, then you can definitely move on to the more advanced stuff, more complicated stuff. So, let me see here. I think what I will do is first restore the title screen. Music. Let's see here. Dates. Didn't have the like play. Yeah, play audio. So instead of playing the low time song, we'll play the title song, which is the correct song for the title screen. Resets. So the title, as we can hear, is definitely doing a lot more with its main channel. So now, let's actually go to the title screen's music data. So right here. So I was actually tinkering with this a little off stream as well. So this was D3. The 3 values. And in the title screen's case, it has that little drum intro, so that's what these note rests are for. And we got E. Did that previous song have an E6 as well? Alright, because yeah, I also figured out some of the tones here as well. So what the title screen does, it jumps to this one pattern, which is kind of fading in the notes. So reset this real quick. So we just wait a little bit. We're gonna hear the notes fade in. So FD is always that jumping effect, which is leading me to believe then that because yeah, here we go. One sec here. Because when it does it kind of like does that do do do, and then it fades, then it's a little bit louder. Do 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 do. Let's reset that. Let it play one more time. So each time it does that, the little sequence is a little bit louder. So that's leading me to believe then that F4 is some kind of volume control. So kind of like with the octaves from earlier, like the higher the value, the lower the volume. So you can kind of think of it as like a negative number in this case. So let's, yeah. And then it's jumping to the same address 4 times. All right. Build and restart. Actually, let's, instead of this, let's do the opposite. F0, F1, F2, and F3. So in this case, it should start out loud and then go quieter. It works. So those are volume controls. Cool. Kind of like a global volume. Well, not global, but for the channel. So these are volume controls. Higher equals quieter. Of course, I'll want to transfer that comment to the main music engine afterwards. Then we have another FD. Which in this case is going to a different spot. I don't know if you're still here, Wally, but yeah, this, so in the NES, it's little endian. So like byte-wise, it would look like, if you look here, like 0B, 9E, but address-wise, that's supposed to be 9E, 0B. So, you know, least significant byte first. So instead of DB, we'll do DW, and then 9E, 0B is what the address actually is. And so 9E0B is down here. This is DCB, right? Yeah, right here. And zoom out again. It's going on about 6:30, so I'll have to probably be leaving soon because it's going to be dinner time. Oh, cooking some dinner? Yeah, just like me. Are you also on the, like, what do you call it? Where are you located? Oh, F4, F3, F2. There we go. Ah, Australia. Okay, cool, cool. Yeah, so it's pretty much the same or similar time as here in Japan then. So that's good, yeah. Yeah, last time I did one of these, it was much later at night too, during a weekday. So, all right. Maybe tinker with this little pattern here, and then we'll probably have to call it. So you have D, which has the 3 follow-ups. Then we have E9, and then E4, which we determined was octave control. Then we have FB, which we determined was kind of like a start of a sandwich, so to speak. Oh, FB, FB. Because yeah, after it fades in. It's still the old build, but so do. It's doing something to repeat this note here, I think. Maybe that's what this is, the 5? Yeah, maybe, hang on a sec here. Going back to the low time thing here. So that's probably not a note. That's actually a counter. Okay, so we're going to test this, and this will be the last thing we test tonight. So instead of repeating the note 5 times, let's maybe try to repeat it, I don't know, 60 plus times. See if that works, as I'm thinking it's going to. So after the fade in, it should do the note a bunch of times. Yep. Cool. So FB and FE are like a set for do this particular pattern n amount of times. All right. That's cool. So definitely figured out a lot of how the format actually seems to be working. Next thing would be to, the more minute things like, changing instruments and whatnot. Another thing I didn't really see thus far is if there's a way to change the tempo of the song as well. Because, see, if you only had 15 lengths of notes, that would seem awfully restrictive. Yeah, there's got to be some kind of like little tempo adjuster. Oh, then again, maybe there's not. Maybe all the songs in this game do play at the same tempo. I don't know. But anyway, all right. Let's change views here. So I think that's going to be it for tonight. Definitely made some progress with this. Sorry if the first half was probably not as interesting because that was just a lot of code analysis. But it helped with making a lot of theories about, what the actual bytes actually, what they do, and then finally testing those theories. Yeah. So I'm not sure what I'm going to do next, if I'm going to do more of the music engine or if we'll actually do more of the gameplay. But yeah, we'll definitely need to, I don't know, definitely needed to see how it goes and then go from there. But anyway, yeah, thanks all for coming in. Let's do a quick ending card here. Yeah, it's also hard to organize the desktop for these programming streams just because I have so much stuff open. Anyway, quick end card here.